The inspector likely means a potential interference issue with dimming controls. If the common conductor of the dead-end three-way switch is used to feed another light source, it can create a path for current to flow through the dimmer control device, even when the lights controlled by the three-way switch are turned off. This can interfere with the proper operation of the dimmer, possibly causing it to flicker or even fail. To avoid this interference, a separate conductor should be used to feed the additional light source directly from the power source. This will prevent current from flowing through the dimmer control device when the three-way switch-controlled lights are turned off. The neutral conductor should not be connected to the common terminal of the dead-end three-way switch. The neutral conductor should be connected to the neutral terminal of the three-way feeder switch and should not be wired through the common terminal of the dead-end switch. Ensure your wiring complies with applicable electrical codes. Consult a qualified electrician or refer to the National Electrical Code, also known as the NEC, for specific requirements and guidelines. Now let's break this down further into the specific electrical principles at play. Firstly, consider the fundamental operation of a three-way switch circuit. A standard three-way switch setup allows a light to be controlled from two different locations. It achieves this by using two three-way switches and a set of traveler wires connecting them. One switch is considered the source switch, or the feed switch, which receives power from the circuit breaker. The other switch is the load switch, sometimes referred to as the dead-end switch, which controls the flow of power to the light fixture. The traveler wires act as a pathway for the current to change direction based on the position of the switches, thus turning the light on or off from either location. Secondly, understand the role of the common terminal. Each three-way switch has three terminals. One is the common terminal, and the other two are traveler terminals. At the source switch, the incoming hot wire, the ungrounded conductor from the breaker, is connected to the common terminal. At the load switch, the common terminal is connected to the light fixture. The traveler wires are connected to the remaining two traveler terminals on both switches. This configuration allows the current to flow to the light fixture when the switches are in the correct positions. Thirdly, identify the problem with using the common for an additional load. The issue arises when you attempt to tap into the common terminal at the dead-end three-way switch, the load switch, to power an additional light fixture, especially when a dimmer is involved. The common terminal at this switch is only intended to provide power to the originally intended light fixture. When you add another load, especially one with a dimmer, you are potentially creating an unintended current path. This unintended path can lead to several problems. Fourthly, describe the potential interference with dimming controls. Dimmers work by rapidly switching the power on and off to reduce the average voltage supplied to the light. When a dimmer is used in conjunction with a three-way switch, it is usually installed at the source switch location. If you tap into the common at the dead-end switch to feed another light, the current for that additional light may flow back through the dimmer, even when the three-way controlled light is off. This happens because the traveler wires and the internal circuitry of the switches can create a path for current to leak back to the dimmer. This unintended current flow can cause the dimmer to malfunction. It might flicker, buzz, or not dim properly. In some cases, it can even damage the dimmer. Fifthly, provide the solution a dedicated circuit. The recommended solution is to run a separate dedicated circuit for the additional light fixture. This means running a new cable from the circuit breaker to the location of the new light fixture. This cable should include a hot wire, a neutral wire, and a ground wire. The hot wire connects to the breaker, the neutral wire goes to the neutral bus bar in the panel, and the ground wire goes to the ground bus bar. By running a dedicated circuit, you are ensuring that the current for the new light fixture does not interfere with the three-way switch circuit or the dimmer. Sixthly, elaborate on the importance of proper neutral connections. In a standard electrical circuit, the neutral wire provides a return path for the current to flow back to the source. The neutral wire is typically connected to the neutral bus bar in the electrical panel. It is essential to ensure that the neutral wire for the three-way switch circuit and the neutral wire for the new light fixture are properly connected. As mentioned previously, the neutral for the three-way circuit should not be connected to the common terminal of the dead-end switch. It should instead be connected to the neutral terminal of the three-way feed switch. Similarly, the neutral wire for the new light fixture should be connected directly to the neutral bus bar in the panel, not to the common terminal of the dead-end switch. Seventhly, explain code compliance and safety. All electrical work must comply with the National Electrical Code, or NEC, and any local electrical codes. These codes are designed to ensure the safety of people and property. When working with electrical wiring, it is essential to follow all applicable codes and best practices. Some specific NEC requirements that might be relevant to this situation include those related to wiring methods, conductor sizing, overcurrent protection, and grounding. If you are not comfortable working with electrical wiring, it is best to consult with a qualified electrician. An electrician will be able to ensure that the wiring is done safely and correctly and that it complies with all applicable codes. Eighthly, discuss multi-wire branch circuits. Since a multi-wire branch circuit, or MWBC, is involved, special attention must be paid to neutral connections. In an MWBC, two or more ungrounded conductors share a common neutral conductor. These circuits are typically used to provide both 120 volts and 240 volts in residential settings. When working with MWBCs, it is critical to ensure that the neutral conductor is properly sized and that it is not overloaded. Overloading the neutral conductor can cause it to overheat, which can lead to a fire. Additionally, it is important to ensure that the ungrounded conductors are connected to different phases in the electrical panel. This helps to balance the load and the neutral conductor. Ninthly, analyze the specific scenario provided. The original question described a scenario where the hot wire from the three-way switch was being used to feed an outdoor light. The neutral for the outdoor light was being taken from the common neutral in the multi-wire row mix already in the box. This configuration is problematic for several reasons. As discussed earlier, tapping into the common terminal of the dead-end switch can cause interference with dimming controls. Additionally, using the common neutral in the multi-wire row mix may overload the neutral conductor. The neutral conductor in an MWBC is only designed to carry the unbalanced current from the ungrounded conductors. If you add an additional load to the neutral conductor, you may exceed its capacity. Tenthly, provide specific recommendations for this scenario. Based on the information provided, the following recommendations can be made. Firstly, disconnect the outdoor light from the common terminal of the dead-end switch. Secondly, run a dedicated circuit for the outdoor light from the circuit breaker. Thirdly, connect the neutral wire for the outdoor light directly to the neutral bus bar in the electrical panel. Fourthly, ensure that the neutral conductor in the multi-wire row mix is properly sized and not overloaded. Fifthly, consult with a qualified electrician if you have any questions or concerns about the wiring. Understanding potential dimmer interference, recognizing proper neutral connections, ensuring code compliance, and addressing multi-wire branch circuits can help avoid problems and guarantee a safer electrical installation. Let's expand on each of these points to provide an even more comprehensive understanding. Regarding dimmer interference, it's important to delve deeper into how dimmers function and how they interact with various types of lighting loads. Dimmers, in their most basic form, control the brightness of a light by reducing the amount of voltage supplied to it. Older dimmer designs used a rheostat, which is a variable resistor, to dissipate excess energy as heat. Modern dimmers, however, use electronic components like triacs or silicon-controlled rectifiers, also known as SCR, to rapidly switch the power on and off. This switching action effectively reduces the average voltage supplied to the lamp, thus dimming the light. The speed at which the dimmer switches the power on and off can create electromagnetic interference, or EMI, which can affect other electronic devices. When a dimmer is used in a three-way switch circuit, the potential for interference is increased due to the added complexity of the wiring. As previously mentioned, tapping into the common terminal of the dead-end switch can create an unintended current path that allows current to flow back through the dimmer even when the three-way controlled light is off. This unintended current flow can not only cause the dimmer to malfunction but also generate EMI that can interfere with other devices in the home. Different types of light sources can also affect the performance of dimmers. Incandescent lamps, which are becoming less common due to their energy inefficiency, are generally the easiest to dim. LED lamps, on the other hand, can be more challenging to dim because they have different electrical characteristics. Some LED lamps are not dimmable at all, while others require specific types of dimmers that are designed to work with them. Using the wrong type of dimmer with an LED lamp can cause flickering, buzzing, or even damage to the lamp or dimmer. Compact fluorescent lamps, also known as CFL, are also more difficult to dim than incandescent lamps. Like LED, CFL requires specific types of dimmers that are designed to work with them. In addition to the type of light source, the wiring of the three-way switch circuit can also affect dimmer performance. Long wire runs can introduce voltage drop, which can cause the dimmer to malfunction. Loose connections can also cause problems, such as flickering or buzzing. When troubleshooting dimmer problems in a three-way switch circuit, it is important to check all of the wiring connections to ensure that they are tight and secure. It is also important to make sure that the dimmer is compatible with the type of light source being used. Regarding proper neutral connections, it's essential to emphasize the critical role that the neutral conductor plays in maintaining a safe and reliable electrical system. The neutral conductor provides a return path for the current to flow back to the source. In a properly functioning circuit, the current flowing through the hot wire should be equal to the current flowing through the neutral wire. If the neutral conductor is not properly connected, it can cause a variety of problems, including voltage drop, overheating, and even electrical shock. One common mistake is to connect the neutral wire to the ground wire. This can create a ground loop, which can cause unwanted current to flow through the grounding system. Ground loops can be particularly problematic in sensitive electronic equipment, such as audio and video systems, as they can introduce noise and interference. Another common mistake is to overload the neutral conductor. This can happen when multiple circuits share a common neutral wire. The neutral conductor must be sized to carry the total current from all of the circuits that it serves. If the neutral conductor is too small, it can overheat and potentially cause a fire. In multi-wire branch circuits, the neutral conductor is particularly critical. As previously mentioned, an MWBC consists of two or more ungrounded conductors that share a common neutral conductor. The ungrounded conductors are connected to different phases in the electrical panel, which helps to balance the load on the neutral conductor. However, if the ungrounded conductors are not properly balanced, the neutral conductor can become overloaded. To prevent overloading the neutral conductor in an NWBC, it is important to ensure that the loads on each ungrounded conductor are as balanced as possible. This can be achieved by distributing the loads evenly across the different circuits. It is also important to use a neutral conductor that is sized appropriately for the total load. Regarding code compliance, it's crucial to understand that the National Electrical Code, or NEC, is a comprehensive set of standards that governs the safe installation of electrical wiring and equipment. The NEC is updated every 3 years, and it is important to stay current with the latest edition. The NEC covers a wide range of topics, including wiring methods, conductor sizing, overcurrent protection, grounding, and bonding. It also includes specific requirements for different types of occupancies, such as residential, commercial, and industrial. Compliance with the NEC is essential for ensuring the safety of people and property. Failure to comply with the NEC can result in fines, penalties, and even legal action. In addition to the NEC, many local jurisdictions have their own electrical codes that may be more stringent than the NEC. It is important to check with your local building department to determine the specific electrical codes that apply in your area. When working with electrical wiring, it is important to obtain any necessary permits before starting the work. Permits are typically required for new construction, renovations, and additions. The permit process involves submitting plans to the building department for review and inspection. Once the plans are approved, the building department will issue a permit which authorizes the electrical work to begin. After the electrical work is completed, the building department will conduct an inspection to ensure that the work complies with the applicable codes. If the work passes inspection, the building department will issue a certificate of occupancy which allows the building to be occupied. Regarding multi-wire branch circuits, it's important to reiterate the unique characteristics of these circuits and the precautions that must be taken when working with them. As previously mentioned, an MWBC consists of two or more ungrounded conductors that share a common neutral conductor. The ungrounded conductors are connected to different phases in the electrical panel, which helps to balance the load on the neutral conductor. However, if the ungrounded conductors are not properly balanced, the neutral conductor can become overloaded. One of the key considerations when working with MWBCs is the sizing of the neutral conductor. The neutral conductor must be sized to carry the maximum unbalanced current from the ungrounded conductors. The NEC provides specific guidelines for sizing the neutral conductor in MWBCs. Another important consideration is the identification of MWBCs. The NEC requires that all MWBCs be clearly identified at the electrical panel. This can be done by labeling the circuit breakers or by using a common trick breaker that simultaneously disconnects all of the ungrounded conductors. When working on an MWBC, it is important to disconnect all of the ungrounded conductors before working on the neutral conductor. This will prevent the possibility of electric shock. It is also important to use a voltage tester to verify that the circuit is energized before starting work. In summary, when dealing with electrical modifications or installations, always prioritize safety by understanding circuit behavior, adhering to code regulations, and seeking professional advice when necessary. The potential for interference with dimming controls can be mitigated by using dedicated circuits for additional loads, ensuring proper neutral connections, and verifying compatibility between dimmers and light sources. Code compliance ensures that all electrical work meets the minimum safety standards set forth by the NEC and local jurisdictions. Multi-wire branch circuits require careful attention to neutral sizing and load balancing to prevent overloading and potential hazards. By understanding these concepts and following best practices, one can safely and effectively perform electrical work while minimizing the risk of interference, overheating, and electrical shock. Always consult with a qualified electrician if you have any doubts or concerns about electrical work. Their expertise can help ensure that the work is done safely and correctly, and that it complies with all applicable codes. Remember, electricity can be dangerous, and it is always better to be safe than sorry.